Hello everyone. Um, I'm just going to solve STP and then STP gas stoic problems today for reference in preparation for your second long quiz. So, uh, let's first start with number one. So, it says here that when calcium carbonate is heated strongly, this is the calcium carbonate, CaCO3. Carbon dioxide is released according to the following equation. So when CaCO3 is heated strongly, it produces carbon carbon oxide or carbon monoxide and carbon dioxide. Oh, sorry, this is actually calcium oxide. And then it produces carbon dioxide in the form of gas. So the question here is what volume of CO2, what volume of the gas measured at STP, standard temperature and pressure, is produced if there is 15.2 grams of calcium carbonate. When 15.2 grams of calcium carbonate in solid is heated. So this is clearly an STP problem. So to solve, let's first start balance the equation. So this is actually already balanced. We have 3 oxygen here, and one calcium on the product side, and one carbon in the product and reactant side. So we have 1, 1, 1. So it's already balanced. Then let us first start with um, the given grams. So when we say stoichiometry, guys, this means manipulation. This means manipulation. We manipulate what's given to get what is asked. So the first given here is 15.2 grams. So we know that at STP, we can notice in the problem that there's no given temperature and pressure because it's in standard form. But we know that at STP, 1 mole of any gas, 1 mole of any gas is equal to is equal to 22.4 liters. So we know that in STP, this condition is given. So we go back to the given. We have 15.2 grams of calcium carbonate. And the first term, we should get the what? Molar mass. I hope you're already familiar with the molar mass. It says here that when we have 1 mole of CaCO3, how many we have, how many grams of it over grams of CaCO3. So when we look at our periodic table here, our Ca is 40.078. So to solve for, I'll just show you this one time. CaCO. So we have 1 times 40.078. Calcium is 1 times, no, carbon has 1 times 12.011. Let me check. Calcium has 12.011 and oxygen has 15.99. If you can check here, its atomic mass is 15.9. And there are what? 3 atoms of oxygen. So you get the product of all of this and then sum it. The result would be 100.1 grams. So we put 100.1 grams of CaCO3. The second term, we should be looking at the given moles from the balanced equation. That is why it's very important that we balance the equation first. So we want to cancel out CaCO3, right? So we should use something here as the denominator. We have 1 mole of CaCO3. This is given here. And then what we're looking for is the volume of CO2. The numerator should be mole of CO2. And the mole of CO2, we also have 1 mole of CO2. Then, by STP, we know that 1 mole of any gas, the gas we're talking about here is carbon dioxide, we have 22.4 liters of carbon dioxide per 1 mole of carbon dioxide. Therefore, we cancel this, mole of CO2, mole of CO2. Our final answer is 3.401 liters of carbon dioxide. So we have another problem here again. So from number 1, we know that the volume of CO2 is now 3.401 liters of carbon dioxide at STP through gas stoichiometry. So here we have the synthesis of sodium chloride. Sodium chloride is we know this well, NaCl, occurs according to the reaction. So NaCl is formed when Na in solid and Cl2 in gas are synthesized. The question here is, what volume of chlorine still at STP is necessary for the complete reaction of 4.81 grams of sodium metal? Sodium metal, when we say metal, this is in the form of solid, right? So we don't have any sodium metal aside from Na. And this is what we call Cl2, is what is known as chlorine gas. So to solve, we have 4.81 grams of Na times the first term should always, not always, but the first term here is we need to get the mole from the grams of Na to the mole of Na. We have 1 mole of Na over the grams of Na. So how do we find the grams of Na again? We look at your periodic table. So from your periodic table, your Na is 22.990. So that grams is 22.990. The second term we will be looking at, so I apologize, we should balance this first. This is an unbalanced equation. This should be 2, so that this is 2 and this is 1. So it would be balanced. Second term should, we should cancel the mole of Na and leave mole of what we're looking for, chlorine gas, Cl2. So how many moles of Na do we have? We had 2 moles of Na. And how many moles of Cl2? We have 1 mole of Cl2. Then since it is in STP, the condition at STP, 1 mole of any gas is equal to 22.4 liters. So let's say that we have 1 mole of Cl2, which is a gas. We also have 22.4 liters of that gas. Therefore, we cancel out the terms. Grams, mole, Cl2 of Cl2. Therefore, we have 2.342 liters of Cl2, chlorine gas. So I hope that this is clear. For the third problem, we have potassium permanganate is produced commercially by the reaction. Potassium permanganate. What volume of chlorine gas at STP would be required to produce 10 grams of KMNO4? So our potassium permanganate here is this one. No. Yes, this one. This is our potassium permanganate. And what we're looking for is the volume of the gas, since this is a gas stoic. So this is still at STP. So we use this 10 grams of KMNO4 times its smaller mass, 1 mole of KMNO4 grams of KMNO4. So by now, I assume that you know how to solve for the grams of KMNO4. You have KMNO. It's 1 times its atomic mass, 1 times its atomic mass, and 4 times its atomic mass. So you get the sum of it. You should get 158 grams of KMNO4. So 158.0 grams of KMNO4. So again, don't forget to balance this equation. This should be 2, 1, 2, 2. And let's go back to the second term. We have 2 mole of KMNO4. We have 2 mole of KMNO4 here. And what we're looking for is the chlorine gas. So mole of chlorine gas. And there is 1 mole of chlorine gas. Then, since it's an STP, we should use the condition that per 1 mole of chlorine gas, there is 22.4 liters of it. So we cancel the terms, grams of KMNO4, grams of KMNO4, mole of KMNO4, mole of KMNO4, mole of Cl2, mole of Cl2. Therefore, we have 0.709 liters of Cl2. Okay. So number 4 here is not an STP problem. You will know that the problem is not in STP when there is a given temperature and pressure in it. Okay? So first and foremost, we balance the equation. So consider the following unbalanced chemical equation for the combustion of propane. Propane is C3H8. What volume of oxygen at 25 degrees Celsius and 1 atm is needed to complete the combustion of 5.53 grams of propane? So what we should do is write the givens first. So we have temperature of oxygen at 25 degrees Celsius, which is in Kelvin 298.15 K, and the pressure of 1.04 atm. So this is the temperature of oxygen gas. This is the pressure of oxygen gas. Okay? So this is not non-STP because the temperature and pressure are given in the problem. Then we have 5.53 grams of propane. So we have 5.53 grams of C3H8. So from here, we will use stoichiometry to solve for what? The mole of oxygen gas. So here we know that 1 mole of C3H8 has how many grams of C3H8? 44 grams. You should check this in your periodic table. 3 times CH. 3 times 12.011 and 8 times 1.008. You get the sum of this. Hopefully you will have 44 grams. Then we use the mole from our balance equation. So is this a balance equation? So not yet, right? So the balance equation should be this is 1, 3, 4, and this is 5. So for the second term, we have how many mole of C3H8? And what we're looking for is oxygen gas, mole of O2. So we know that we have 1 mole of C3H8, we have 1 mole of propane, and 5 mole of oxygen gas. So the third term, which we usually do, the 22.4 liters here, is not applicable since it is not non-STP. So we simply get the product of this all, of it all. So this we have cancel this one. Cancel this one, and then we have 0. Change that. 0.628 mole of oxygen gas. We know that this is what? Mole is N, denoted by N, 628 mole of O2. So notice that we have everything we need to use for the ideal gas equation. We have P of O2, T of O2, and N of O2. So if you recall, you should recall that the ideal gas equation is PV/nRT, and we're looking for the volume of oxygen. Therefore, we have V equals nRT over P. And our ideal gas constant here, it should be noted that since this is in ATM, the ideal gas constant is 0.0821 L of ATM, L times ATM over K is 2 mole. So therefore we have 0.628 mole and R is 0.0821 L ATM K mole times T. I'll just insert this here. 298.15 Kelvin over T, which is 1.04 atm. Your volume should be what? Your volume should be equal to 14.781 liters of oxygen. So this is the final answer. So for problem number 5, we have if water is added to magnesium nitride here is Mg3N2. Ammonia gas, magnesium nitride is Mg3N2. We have water is of course H2O. H2O. And ammonia is NH3. Ammonium is NH4, but ammonia is NH3. And we have magnesium oxide here. So when excess water is added to 10.3 grams of magnesium nitride, what volume of ammonia gas would be collected at 24 degrees Celsius and 752 mmHg? So again, is this an STP or non-STP problem? Note that the temperature and pressure here are given in the problem. So this is a non-STP problem. So first we balance the equation here. So the balance equation for this is 1 3 3 2. And then we write the given. So what volume of ammonia gas would be collected at? So temperature is 24 degrees Celsius or 297.15 Kelvin. This is the temperature of the ammonia gas. And the pressure here is 752 mmHg. We can always convert this to atm by converting this to atm. 1 atm is equal to, we should know that 1 atm is equal to 760 mmHg. So this is 760 mmHg for us to convert. This is 0.989 atm. Atmospheric pressure of what? Ammonia gas, NH3. So what we should do is find the mole of NH3. So we can use PV and RT, the ideal gas equation, later. So how do we find the mole? We use the grams and use stoic. So we have 10.3 grams of magnesium nitride, Mg3N2. And then its molar mass, 1 mole of Mg3N2 has, so for the molar mass, it should be 109 grams of Mg3N2. And then the moles from the balance equation, we have 1 mole of Mg3N2 from here, and what we're looking for is volume of ammonia gas. So we should know the mole of ammonia gas. So ammonia has 2 moles. Therefore, this is what? 0.204 mole of NH3. Therefore, we have found our mole, 0.204 mole of NH3 here. So, we have this temperature of NH3, we have pressure of NH3, and mole of NH3. Don't forget that since the ideal gas constant, which is R 0.0821 L ATM K mole, since the pressure is in ATM. Now we use our PV equals nRT to get the volume of ammonia gas, nRT over P. So V is actually 0.204 mole of NH3 and 0.0821 L of ATM over K mole. And the temperature is 297.15 K divided by P, which is what? P is 0.989 ATM. Therefore, volume, when you solve for this, mole of NH3, mole, ATM, K, and K. For your final answer should be near 5.03 L of NH3. Okay. So for the last part, we have this problem. Ammonia and gaseous hydrogen chloride combine to form ammonium chloride according to this equation. So notice that this problem is somewhat different from the previous examples. We have 4.21 liter of NH3 at 27 degrees Celsius and 1 ATM. So these are givens for NH3. And there are two gases here. So it's combined with 5.35 liter of HCl at 26 degrees Celsius and 0.998 ATM. The question is, what mass of NH4Cl will be produced? And notice here that there's a limiting reactant, which I'll explain later, and an excess reactant. So what we need to do first is balance the equation. So this is 1, 1, 1. This is already balanced. And write our given. So we have two gases actually. We have two gases. So we have NH3 and HCl. For NH3, the volume is 4.21 liters. The temperature is 27 degrees Celsius or 300.15 Kelvin. And the pressure here is 1.02 ATM. For the HCl, the volume is 5.35 liters. The temperature is 26 degrees Celsius or 299.15 Kelvin. And the pressure is 0.998 ATM. What we should do next is solve for their moles separately, and then we will decide which is the limiting reactant, or which gas, these both are in gas, which gas is the limiting or the excess reactant. Okay, so So to start, we have N. Let's start with N of NH3. So the given here is since this is PV and RT, this is PV equals nRT. N is equal to RT over PV. So N of NH3, we have R is 0.0821 L ATM K mol. T is 300.15 Kelvin divided by P 1.02 ATM, and V is 4.21 L. So your N is 0.7174 mole of what? NH3. So we have this. N is actually 0.174 mole for NH3. Please also solve the N for HCl using the same process. You just use what's given in this side. So you should have 0.218 mole of HCl. Let me know in the comment section if you also got 0.218 mole. So for HCl. So the mole for HCl is 0.218 mole of HCl. Now, so the question here is what mass of NH4Cl will be produced? Which gas is the limiting reactant, and which gas is the excess reactant? Please remember this, that okay, I'll just write this here. Please remember this sentence. It says here that the reactant that produces a lesser amount of product is the limiting reagent. Lesser amount of product is the limiting reagent. The reactant that produces a larger amount of product is the excess reagent. So, therefore, looking at their mole, this we should know by now that NH3 gas is the limiting reactant, and HCl is the excess, since HCl, the mole of HCl is greater than the mole of the ammonia gas. So, by definition here, if you can see my screen, the limiting reagent in a chemical reaction is the reactant that will be consumed completely. So, in Bisaya, ang limiting reagent kay moto siya ang mahurot, ma-consumed completely. And once there is no more of that reactant, the reaction cannot proceed. Therefore, it limits the reaction from continuing. Meanwhile, the excess reagent is the reactant that could keep reacting if the other had not been consumed. So, it means that if dili mahurot si ammonia, ang gasigig react is si HCl. So, since si ammonia gas is the limiting reactant, this is what we should use as the reagent na the reactant to find the NH4Cl. So, the limiting reactant, in definition nga need complete ang reaction, mo itong gamiton to find the mass of NH4Cl. So, let's solve. Let's always use the limiting reactant. We have 0.174 mole of NH3. We have 1 mole of NH4Cl and 1 mole of NH3. This is the molar, not the molar mass, but gas stoic. And then we have 1 mole of NH4Cl. How many grams of NH4Cl do we have? So notice that this is what we get by looking at the balanced chemical equation. We have 1 mole of NH3 and we have 1 mole of NH4Cl. Then we get its molar mass. So this should be 53.5 grams. You should know how to get the molar mass. Therefore, we have 9.309 grams of NH4Cl. And that's it. This is our final answer. Okay.